In pursuit of sharing technical knowledge and just to gear up the new generation of engineers, myself Pranav is here to deliver today's presentation, Power Transformer Part 44. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with the nature of power quality problem. Power quality problem is directly linked with transformer. Now, the nature, first nature is voltage transient. Second one, variation in short duration. Third one, variation in long duration. Voltage unbalance. Waveform distortion. Voltage fluctuations. The voltage transient, there are two types. One, impulsive type, another is oscillatory type. The nature of power quality problem, if the variation in short duration, then there are three types of nature we have observed. One is instantaneous, two momentary, and third one is temporary. In instantaneous, that is the interruption, voltage sag or voltage dip, voltage swells, that is voltage higher voltage. In momentary case, interruption, voltage sag, that is dip, voltage swells. Number three, temporary, that is interruption, voltage sag, voltage swells. Variation in long duration, same thing, interruptions, voltage over voltages, under voltages. Voltage unbalance, DC offset, steady state, harmonics, interharmonics, notching, steady state, noise. And the other two is waveform distortion and voltage fluctuations. Now let's discuss with voltage transients. A transmission line, while it has been connected to a voltage source, then the total line would not be energized instantly, and certain time would have to run out in between the process from initial phase to have a final steady state condition. It is a process of voltage wave which is always accompanied by a current wave, and that has to travel along the length of the line at a certain velocity. However, the transmission system network generally operates under a steady state condition. Transient voltages are the most temporary, unwanted voltages which may have initiated due to certain incidents of disturbances like capacitor bank switching on and off, occurrence of short circuit faults on or some lightning discharge. Electrical interference as conducted by the electrical transients that have to initiate from both internal as well as external sources, which has the potential to impact on AC and DC systems. Internal sources, that is switching of capacitor banks. Number two, on and off operation of power semiconductor switches. Internal fault as generated. Electrostatic discharge. Relay actuation. Sudden opening or closing of circuit breakers or switch gears, sudden load addition or load throw off, and the last one is arcing. This is all the internal sources. And the external sources, that is lightning incidents, sudden external load addition or removal, sudden opening of or closing of circuit breakers or switch gears in energized systems, switching of capacitor banks, tap changing operation in transformers, external faults, and the last one, short circuits at neighboring circuits. Lightning is an external source that generates transients in electrical circuits, and the voltage as well as current will have to pass through a transient state before attaining steady state conditions. Any momentary fluctuations of the electrical power as connected to AC or DC circuit would have to occur transients which invariably affect the normal voltage and current. A transmission line is a circuit with distributed parameters, and in steady state conditions, the composite circuit has to support the traveling waves of nominal voltage and current, with having the system network that has always to maintain a, a finite velocity of electromagnetic field propagation. Superimposed voltage wave as caused by the transients has to change the resultant value of the voltage as well as the current, which would have been higher in magnitude as compared to those in steady state conditions. The transient phenomenon would have the duration mostly in the range of microseconds to several milliseconds, which obviously depends on the circuit parameters such as resistance, inductance, capacitance, etc. Transients are the short duration power quality disturbance, and the potential impact of transients can be additive or subtractive to nominal steady state waveform energy. Waveform means current waveform as well as voltage waveform. That is distortion in voltage or current waveform. Transients are also associated with abnormal changes in frequency, which can rise up to 5 megahertz. The reflection of the severity of transients can vary with the subsequent locations and environment in which the corresponding grid and its associated electrical equipment will operate. As of the nature of conducted interference events, transients are generally categorized by impulse transients and oscillatory transients. There are several potential sources of instigating transient events, and their waveforms used to simulate these events can vary significantly. A. Electrical first transients. Electrical first transients, that is EFT, are a series of quick high frequency pulses often caused by arcing, which would have to occur at the very instance of making or breaking of an AC or DC connection, equipment suddenly out of circuit, or circuit breakers switched on and off. Electrostatic discharge is of the common factor for generating the electrical fast transients, and it can have massive interference on transmission network. Impulse transients. Impulse transients are the combination of wave surges which are first increases in voltage and or current characterized by a primary positive or negative priority with duration generally less than 1 millisecond. The duration is very less, 1 millisecond. As per IEEE 1159 2019, the impulse transient is an interference to have a certain non-power frequency change in the steady state condition of voltage or current or both that has unidirectional polarity, either positive or negative. Impulsive transients may have to instigate during lightning switching of lines to power factor correction, capacitor banks, poor grounding arrangement, switching of inductive loads, utility fault during cleaning, that is clearing activities, disconnection of heavy loads, and electrostatic discharge. Impulsive transients are characterized by their speed with rise and decay times. Nature of impulsive transients: extremely fast transients, medium fast transients, slow transients. Extremely fast transients, which is the rise from 0 to peak value, is about 5 nanosecond rise, and typical duration time less than 50 nanoseconds. Medium fast transients, which is 1 microsecond rise and its duration 50 nanoseconds to 1 millisecond. Slow transients, that is 0.1 millisecond rise and duration more than 1 millisecond. Points to be noted: it is of much importance to note that the impulsive transients can have to excite the natural frequency of power system circuit, and that may lead to produce oscillatory transients. Again, I repeat, it is of much importance to note that the impulsive transients can have to excite the natural frequency of power system circuit, and that may lead to produce oscillatory transients. See the diagram: current impulse transients caused by lightning stroke. As of the consequences of impulsive transients, number one, nanosecond transients would generally have to occur nearer to the source of disturbance. There would be of 5 nanosecond rise time from steady state to the peak of the impulse with a duration of less than 50 nanosecond. Number two, microsecond impulsive transients are relatively unusual, but would have much higher amplitudes. On electrical system, though they are not conduct as easily as of the millisecond types, but may cause arcing fault. There would be of 1 microsecond rise time from steady state to the peak of the impulse with a duration of 50 nanoseconds to 1 millisecond. Millisecond impulsive transient would be the most common to occur in a power system. There would be of 0.1 millisecond rise time from steady state to the peak of the impulse with a duration of more than 1 millisecond. A single electrical first transient voltage pulse and waveform. 1. See the left portion of the peak value. Left portion of the peak value is called the wavefront. Right portion of the peak value is called tail of the wave. T1 is the time taken to attain peak value. T2, time taken for the tail to fall 50% of the peak value. And last one, 5, pulses are categorized by the rise time, duration, and peak value, which is thus to be correlated to a particular level. The insulation failure in high voltage equipment are mainly due to over voltages, and that has to initiate from lightning and switching operations in high voltage energy transmission and distribution systems. Transformers are of the high inductance device, and when subject to transient voltages that may possibly produce high electrical field stresses on their active part, which can cause a certain failure of their insulation system. The international standards are therefore always to suggest for performing impulse voltage tests on each and every HV equipment to confirm its insulation performance. The cross-linked polyethylene underground cables, that is XLPE underground cables, are extensively used for all voltage levels of AC system, and after having long time in service, the probability of failures are being caused by internal defects in the cable insulation system. A typical characteristic of cable accessories is always to support for propagating the traveling waves of voltage and current as instigated by the switching operations or lightning strikes, which thus to be superimposed on the existing finite velocity of electromagnetic field propagation of operating power frequency AC voltage and current. In consequence of these transients, there would have been certain changes in electrical stresses throughout its entire insulation system. As of the study, as of the study, it has been concluded that partial discharges over time, as triggered due to occurrence of impulse transients, will cause insulation to degrade. Again, I repeat, as of the study, it has been concluded that partial discharges over time, as triggered due to occurrence of impulse transients, will cause insulation to degrade. However, the partial discharge is not at all a continuous process. Partial discharge would have to initiate only when the voltage level reached to the partial discharge inception voltage, which is called PDIV. partial discharge inception voltage. Partial discharge would have to initiate only when the voltage level reached to the partial discharge inception voltage. Once initiated, partial discharge will continue until the voltage level dips below the partial discharge extinction voltage, that is PDEV. As with the increase of degradation phenomenon of insulation material, that is PDIV and PDEV, both would have been decreased. That leads to instigate the partial discharge activity at a lower voltage level. The destructive consequences that would have to expedite partial discharge activity more and more severe once the conductive channels will form in the insulation material. Oscillatory transients. Oscillatory transients, as of the nature of the transient waves, the oscillatory transients have to differ from impulsive transients. An oscillatory transient is of the bidirectional in polarity, whereas an impulsive transient is of the unidirectional in polarity. That is the basic difference between oscillatory transients and impulsive transients. Oscillatory transients is of bidirectional in polarity, and impulsive transient is of the unidirectional in polarity. As per IEEE 1159 2019, an oscillatory transient is an interference to have a certain non-power frequency change in the steady state condition of voltage or current, or both, that has bidirectional in polarity, that is positive and negative polarity values. Oscillatory transients pulses have the characteristics of momentary changes in voltage and or current, where the polarity rapidly changes as the decay in transient values. Depending on the pulse frequency, which has to signify the root source of disturbances, and as a process of frequency, magnitude, and duration, the oscillatory transient pulses can thus to be classified in low, medium, or high frequency transients. Damped oscillatory pulses. Let's stop here. Further to be continued at later stage. Thank you. Thank you for patient hearing. Thank you for listening the video. Kindly do like, share, and subscribe. Your subscriptions would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section. Thank you.